Hello, this is Mensaflow. We're going to take a little look at the Mensaflow architecture, take the hood off, take a look what's inside so you can get a better idea of what you're getting when you engage with Mensaflow here. So here's a little bit of a block diagram. What you see there in blue here, this kind of the internals of the Mensaflow server software. And then in green is kind of external, but it's really part of it in terms of the sensor, the input and responses, the output, which basically communicates with the server, and then the workflow, which is embedded inside the server itself. What you see in the dashed line is what's in the server software itself. And then, of course, it communicates to the outside world, to agents, LLM models, which could be an LLM model through an API or an internal LLM model on the server itself. We'll talk a little bit more about that. Agents and data connectors. And, of course, we have a MySQL database and a vector database to manage all the data behind the scene. Inside the server itself, we have rendering engines, system management system, document management system, the server itself, and the APIs that communicate with the outside world. And of course, servers can be on the cloud. It can be a physical server that you have. So there's lots of configurations in terms of the actual hardware. Let's take a look at the software itself here. And so this kind of shows you all the different servers running on the server itself. What's in blue again is on the server. And there's kind of a line, I don't know, it's kind of a demarcation of what's internal versus external. Of course, the external, we have the agents, the LLM models that are available, the chatbox rendering widgets, which is part of the software, but it's of the Mensaflow server, but it's actually executed on the client side, and web pages, obviously, and other sensors, industrial controls, other types of inputs that could come into the server. So in the server itself, everything funnels through the Mensaflow server. You have to have access through via embed codes and API keys, depending on what services you're trying to get. Of course, there's APIs involved. Through that, then internally, once behind the server, it all goes through local ports. So you have to pass through the server through these security mechanisms to get to the local ports. So all these other servers are running on local ports, like, for instance, the vector database, MySQL, the document manager. You have to go through the Mensaflow collector, which provides that middleware security. The N8N workflow server, which is also part of the infrastructure, and then of course we use Ollama to basically run local LLM models. So you can run the whole application within the server itself, so you have complete control over that if security is an issue. A little bit about the infrastructure architecture. We kind of have two options. One, you can run the Mensaflow server via a fixed IP port, via a certain port that you define, entities that we talked about earlier. So that's one option. The other option, which is kind of the preferred option for us because it provides extra security, is we run it through Cloudflare. Of course, that provides all kinds of layers of security, DDoS attacks, et cetera, et cetera. So all that puts the Mensaflow server behind the Cloudflare, which provides that extra layer of security. And the Mensaflow server lives in a secure tunnel that's behind Cloudflare, so nobody can get to the server unless they go through the Cloudflare provided security. And this also means that you don't need a fixed IP. A lot of times people want to put their servers in their own premises, but they don't have fixed IPs and don't want to go through that trouble. Well, Cloudflare eliminates that because you can run through that secured tunnel. Now, last thing I want to talk about is, because this is always going to come up as an issue, is this idea of the server configurations. If you would, a lot of people want to buy their own server because of security reasons or just have the control over it. Or run their own LLM models locally, as opposed to hooking into OpenAI or Grok or Mistral, or some of these where they have to use an API, and they want to have all their data and everything. Now, keep in mind all your documents and your vectorial database, that's all local there. Or you can use there's actually options that you can use external vector database like Pinecone or something like this. But the point to this chart is there's always a cost to everything. So as the LM model size increases, so do the costs, and it is an exponential curve. So like there's LLM models you can get that run locally, then between the 7 to 20 gigabyte, and these typically will only need maybe a 16 gigabyte VRAM, whereas you get up to the 70 to 125 gigabyte models, these will take 32 to 48 to 64. This is kind of the thing that you can run locally. Servers, we won't get into the price of servers, but you can kind of guesstimate that yourself. But that's one of our engineers can come in and make that happen. Then you get into some of the bigger models, where obviously the bigger the model, the more intelligence. So it depends on your applications. If it's a simple thing, okay, you don't need big models, don't need big servers. But if you want to get into more complex, and usually clients tend to want to get more intelligence, not less. That's what the big thing about Deepseek. Now, a lot of people say, well, Deepseek is Chinese. Well, you can run the whole Deepseek model locally, and so there's no data that can escape your server. But those are run in the 600, 800 gigabyte size models, and those take some pretty good sized servers. But you can get those local servers. But then you get into the data center type. Like I think Grok has a massive data center down in Memphis, Tennessee, and of course these are external, and people don't want their data going off to foreign data centers. But OpenAI has several monsters, and same with Mistral. All these have data centers, and there's no way an individual server can compete with a data center, obviously. But so it depends if you need it, and you can get into a hybrid situation where, in fact, in some parts of your application you can run it locally, and other parts that you can run it through an API. So that all depends on the architecture. So those are some server considerations. I think the final point here is that it's not that complicated. It may appear too complicated, but if you're familiar with the types of things and the issues involved with building out a server or building out a service, so either it's cloud-based or server-based locally, these issues, we have engineers who can come in and do it fairly quickly. It's not that complicated, but to give you an idea, obviously we've been working with this, we can understand the issues involved. Anyway, don't forget to subscribe to the channel, and on the way out, don't forget to like the video and stay tuned for more.